do, all I am asking for is, given this angle measure right here, the opposite side is this vertical piece right here, right? It's what the angle opens up to. You can always find the hypotenuse, and what helps create the angle is the adjacent side. So if I look at the other triangle, my hypotenuse still remains in the same position, but when I refer to this top angle, then what happens? This becomes the adjacent side, and this becomes the opposite side. So the only thing that switches is opposite and adjacent based off of which angle measure you are making reference to. Now the whole concept of sine, cosine, tangent, which are known as the trig functions, is just to show this ratio. You want the ratio of two sides, whether it is opposite and hypotenuse, we're going to call that sine, adjacent and hypotenuse, which they call cosine, or if it's opposite and adjacent, which is tangent. Now you can take the reciprocals of those, and we're going to talk about that today too. So we're going to look at different things. Okay, the first thing I'm going to do is I'm going to pass out to you your notes. Okay, here we go. The very first thing in your notes, it says evaluate the 6 trig functions of the given angle. So if I were to evaluate them, all that they are asking for is that ratio of the sides. And what sides? What's sine again? Opposite and hypotenuse. Okay, if I get in trouble for saying this on something that's recorded, you guys back me up. Some old hippie caught another hippie tripping on acid. So sine is the relationship or the ratio of the opposite side to the hypotenuse. Cosine is the ratio or the relationship between the adjacent side and the hypotenuse. And tangent is the comparison of what two sides? Opposite over adjacent. Now what I'm going to throw in there when they say 6, because that's only 3. I don't know something else to add on to my some old hippie, caught another hippie thing. But what we can do is we think of reciprocals. And when we think of what's the reciprocal? Flip it. You flip it. So if you look, they have listed for you 3 more values down there. You see a CSC. CSC stands for cosecant. And cosecant is going to be the reciprocal of sine. So that ratio is going to be the hypotenuse over the opposite side. Cosine, its reciprocal is secant. And if you look at secant, when you write secant down, it looks like cosine spelled backwards. Okay, the vowel is wrong, but that's the way I remember it. It looks like cosine spelled backwards. So the reciprocal, or secant, being the reciprocal of cosine, is going to be the hypotenuse over the adjacent side. And the last thing you have is cotangent, which is the reciprocal of tangent, which is the adjacent side over the hypotenuse. So here's, you're just going backwards. Oh yeah, opposite, thank you. I was just ready, I'm trying to think of how I can make you guys memorize this, and I had a good thought going in my head, but I wrote the wrong thing down. Here's how you're going to do it. Just read it backwards. Adjacent over opposite is cotangent. Hypotenuse over adjacent is secant. Now you got to be careful. And hypotenuse over opposite is cosecant. You want the words there? This is actually spelled S-I-N-E, C-O-S-I-N-E, cosine, tangent. The one thing that drives a math teacher up a wall is if you say sin, cos, tan. It's sine, cosine, tangent. And then come over here, and this is cosecant. This is secant. And this is cotangent. Let me pause. So CSC is pronounced cosecant. And it's the reciprocal of sine. Think of it this way. If it begins with S, its reciprocal begins with C. If it begins with C, its reciprocal begins with S. So SEC is secant. So you flip-flop the S and the C. If you flip-flop it, you got to take the reciprocal. I think this looks like cosine spelled backwards, so I know that this SEC says secant, which is the reciprocal of cosine. But otherwise, S and C, C and S. And then, of course, tangent has got to be cotangent. Those just go together. Okay, we got that slide? Yeah. And your notes somewhere? Sorry, I didn't really give you room for that. So here's all they're asking you. They're giving you this figure, if you have your notes, and they're saying, what is the sine? What is the sine of angle A? So here's angle A. Sine is what two sides? Opposite and hypotenuse. What's the opposite side of angle A? 9. And the hypotenuse is 15. Now, I suppose you could reduce that, but I'm not worried about reducing it right now. I'm just going to say it's 9/15. The next thing they ask you is the cosine of angle A. What's the cosine sides? Adjacent over hypotenuse. What's the adjacent side? 12. The hypotenuse is 15. That's all it is. If I go in and I enlarge this, if I enlarge, oh, does anybody recognize what type of a triangle that is? It's a 3, 4, 5 triangle. Guess what happens when I reduce this right here? 3/5. It's a 3, 4, 5 triangle. All it's saying is that if I were to enlarge this by a value of 3 times, this ratio of the sides should still reduce down to 3/5. And it does. They're just saying when those angles remain the same and all I do is I make it bigger or I make it smaller, that ratio between the two sides will always remain as 3/5. Does that make sense what they're trying to tell you? Okay, so then the next thing they ask you, my voice I have a feeling is going to leave me. All the more reason I need to wear flip-flops tonight, right? I feel like I'm getting sick, so wear some flip-flops. Tangent. Tangent is what two sides? Opposite over adjacent. So what's it going to have a value of? 9/12. So the next thing they ask you is cosecant. Cosecant is the reciprocal of sine, so as Eric said, he's correct, it's just going to be 15/9. What about secant? The secant is going to be 15/12, and the cotangent is going to be 12/9. No, not necessarily. Maybe they don't give you the 15. How can I find the 15? Pythagorean theorem or 3, 4, 5 triangle, recognizing as a scale factor of 3. They will tell you which angles they want to make reference to. If they told you the top angle, your values are going to be different. Your angles would be different. Do you want to see what that would be? what if I told you the sine of G? What's sine? Opposite over hypotenuse. But now you're making reference to angle G. So what is the opposite side? 12 over 15. That's how it's going to be different. If I talk about the cosine of angle G, what's that going to be? Adjacent over hypotenuse, which would be 9 over 15. So what happens is these two switch because adjacent and opposite sides switch. Are you okay? Yep. Okay. Didn't know if we were. Okay. Tangent. Does tangent change as well? The tangent of angle G. Tangent is what? Opposite over adjacent. What's your opposite side? 12. The adjacent side is 9. And of course, then your other three functions would be those reciprocals. No, these aren't reciprocals. They're not reciprocals of each other. Well, this is just making you understand what sine, cosine, tangent is. Okay? So what I want you to do is I want you to do the next two triangles for me real quick. Can you do that? Use for your ACT test. Okay. I think calculators are becoming more universal. For an example, some of them, if you wanted the cosine of 30, certain calculators you had to type in 30 first and then hit the cosine key. Others you'd hit the cosine key, then 30. I think now they're becoming more universal in the way that you type that in. Okay, the very first one that comes across on your deal, the tangent of 24. The tangent of 24, all you do is you find the tangent key on your calculator, hit tangent, and then type in 24 and hit the enter key. Now what's going to display on your calculator screen is probably 0.4452 something. Oh no, everybody's in trouble, right? Okay, who got this? Who got this? All right, you guys must have got your calculators at a good place. The rest of you, where did you get them? Online? Walmart. There's the problem. There's the problem. Those are not high quality calculators. No. Does everybody see the mode key? Hit your mode key, and your calculators are probably, when you first get them, they're going to automatically put it in radian mode. No, that's not. You will see radian and you will see degree. Does anybody see radian and degree? You're probably on radian. What you need to do if you have a calculator like this, move your arrow down to where you're at radian and degree, and then push over and then hit enter when it's on degree, because your radian is probably highlighted and degree is not. Highlighted, yeah, it's black with white font instead of the other. But do we have that now? Okay, now just push second function quit to get out of it. Quit is right next to second function. They're right here on your calculator. These two keys. Second function quit. Now it should get you back to the screen. Now push the tangent of 24 on your calculator and see if you get 0.445. Tangent is equal to what? It's the ratio of what two sides? Opposite over adjacent. So they're saying when you have a 24-degree angle, what's the ratio or what's that relationship between those two sides? You can, but right now you use sine, cosine, tangent when you have a 90-degree triangle. If you do not have a right triangle, you can get into what is known as the law of sines and the law of cosines. So right now, sine, cosine, tangent are used when you have right triangles, and it's making reference to the other two angles that are not the right angle. Okay, you have that on your calculator. Here's some different things that you can do. I'm going to pause this real quick because we're going to talk about how you change this over so you can see that as a fraction, because it's showing you as a decimal. And there's multiple ways you can do it based off of your calculator, and I'm going to step around and it's not going to be able to hear me anyway. We were talking about, this is something we were making reference to yesterday. You could use your calculator. I want to know, what is the sine of 30 degrees? So you're going to hit sine on your calculator. Hopefully everybody's in degree mode. And you're going to hit 30 and hit enter. And what do you get for an answer? 0.5. Okay, yesterday we talked about this. By the way, I get a little upset when people just mess with somebody's calculator. I know it seems like it's really funny, but if you just change the mode on the calculator into radians, you know you got a totally different answer for that very first one I had to type in. And if somebody comes in to take a test and they don't realize what mode they're in, and you changed it to radian mode for them, they could be typing everything in correctly, but they're going to miss everything because they're in the wrong mode. So if you have those friends that might like to pull pranks on you, you might want to always check your calculator to see if it's in degree or radian mode. Yeah, you can change them on the just the scientific calculators as well. All right, back to this one. Yesterday, I had something written on my hand. Where was 30 degrees? Ring finger. So I'm going to fold in my ring finger. Was cosine the top fingers or the bottom? Cosine was the top, sine was the bottom. What's this one asking for? The sine of 30 means you're going to look at the bottom numbers. How many do I have there? 1. Radical 1 is 1. What's in the palm of your hand? A 2, which is 1/2. Do you see the relationship? And if I enlarge a 30, 60, 90 triangle, those side lengths are going to get bigger, but when I compare the two, what's it going to reduce down to? 1/2. It will always reduce down to 1/2 if it's a 30, 60, 90 triangle. The opposite side to the hypotenuse will always be 1/2. That's what they get here. The opposite side to the hypotenuse is in the ratio of 1/2. 1 to 2. That's it. You see the connection between all three. The next thing, cosine of 55. They're telling me what's that relationship between what two sides? Adjacent and hypotenuse. So you're going to hit cosine key. You're going to hit 55. You hit enter, and what are you going to get? 0.574 if you round it to 3 decimal places. Now it gets a little more tricky when you start talking about secant, cotangent, and cosecant, because it's what? It's the reciprocal. Opposite means you're going to negate it. So it doesn't mean that if I ask for what's the, is it secant or cosecant that's the reciprocal of sine? Cosecant. It starts with an S, so I want the C, right? So the cosecant of 30 degrees is not negative 0.5, which is the opposite. Be careful of how you're saying it. It's the reciprocal, which is what? 2. Because 0.5 is the same thing as 1/2. It's the reciprocal of that. Yeah, how are you going to type it into your calculator? Okay, the first thing I would do, I'm just going to resort to this one, right? Because we know what it should be. So if they ask me what is the cosecant of 30 degrees, I'm going to go cosecant. Cosecant is the reciprocal of what? Sine. So I'm going to take the sine of 30 on my calculator, and I'm going to get that answer of 0.5. Then here's what you do. How do I show a reciprocal? X to what power is its reciprocal? -1. So there's a -1 key on your calculator right here. Right here. A -1 key on your calculator. Right there. You see it? If you hit that key, it's going to take your answer and it's going to raise it to the negative first, which means it's going to take the reciprocal. If you hit enter, what do you get? 2. And we knew that's what it should be. Okay? Question on that part? If you had it as a fraction, it would still go ahead and take the reciprocal of it. But if you had it as a fraction, I probably wouldn't hit that key. I would look at that fraction that's on my calculator and just flip it myself. So if I look at this one, secant of 72, how do I want to type it in? Secant is the reciprocal of what? Cosine, because it looks like cosine spelled backwards. So I'm going to type in the cosine of 72. So go the cosine of 72. And you get what? 0.309 something. Leave that value on your calculator. And then what do I want to do to get to secant of 72? You hit that -1 key, x to the -1 key. And what's it going to have a value of? It's equal to 3.236. I can tell you this much. Sine and cosine should not be greater than 1. Because in a unit circle that I talked about yesterday, I held that unit circle up, which is over there. Unit circle meant the radius had what length? 1. And that radius was the hypotenuse. So the other two sides had to be shorter than that. And when you compare them, it should be less than 1. Even if you increase it and make it larger, it will reduce down to a value less than 1.
Oh, okay.
But reciprocals can be that, and tangent can be over that. All right, so cotangent, how am I going to type that in my calculator? You're going to take the tangent of 52, so tangent of 52, and then which is going to be 1.2799, and then what do you have to do to that? You have to hit the x to the -1st key. Whoops. Yep. 0.781. So the last one, cosecant, reciprocal of what? Sine. So it's going to be the sine of 40. Let's type in the sine of 40.643. And then you're going to hit that x to the -1 key to get the reciprocal. And you get 1.556 if you round to 3 decimal places. I don't know. It depends on if they tell you. Now, something else that I want to point out. Some of you see that on your calculator, you have this key that says sine. What's above it? Sine to the -1st. Now, you might think that that means reciprocal. What's the sine of 30 degrees again? 1/2. What's the reciprocal of that? 2. I want you to hit that sine to the -1. So go second function sine key. That should put the sine to the -1 power. And hit 30 and see if you get 2. Error. Does not work, does it? Okay. I'm going to explain to you what that little key means. That little key right here is referring to something known as the inverse, not the reciprocal. Don't get it confused as x to the -1. Now, what an inverse means is something else that could be written as the arc sine. Okay, that looks really confusing too, right? But when I say arc, it begins with A, I'm going to think of angle. When you use this key right here is when they ask you a question like this. The sine of what angle equals 1/2? The sine of what angle equals 1/2? Oh. We know that. We put our hand up here. There's your 1/2 for sine, right? What angle measure was that? 30 degrees. This should have a value of 30 degrees. Go second function, and then hit your sign key. So if I were given this question right here, you are asking for the angle. To find the angle, you type it in your calculator. That's what that little exponent of a -1 meant there, the inverse function. So type in that on your calculator. So go second function sine, second function sine, and then 1 divided by 2 or whatever. And what do you get? 30 degrees. So that little exponent to sine, cosine, tangent is finding what for you? The angle. Because you're going to be given what? The sides. Let me ask you this. So when you come back to something like this, this was a 3, 4, 5 triangle, right? Is a 3, 4, 5 triangle the same thing as a 30, 60, 90 triangle? Is it the same thing as a 45, 45, 90 triangle? No. Let's figure out what that is. What is that angle A? Well, that's what you have right here. The sine of angle A is equal to 9/15 or 3/5, right? So if I want to know what is this angle measure right here in a 3, 4, 5 triangle, what is that angle measure, the smallest angle measure? You are going to type in the inverse sine of the ratio of those sides. If I'm using sine, I'm going to go 9/15 or 3/5. So what is that angle measure? This is a 36.87 degree angle.
I have a question. I just put in 915.
Uh-huh.
And it got me 0.01047.
No. Did you do shift sign? Who messed with his calculator? Changed the mode. The question was, can we just use our calculators? I suppose you probably could, but what did I tell you? Austin sent back a question because what? He can't use the calculator. What do you always have with you? If they can't use the calculator, they are going to have to go to specific angle measures such as 0, what's the next one? 30, 45, 60, 90. They're going to have to go to those reference angles. Now keep in mind, when you flip that over into the second quadrant, when you put it in the third quadrant, when you put it into the fourth quadrant, you could be talking about 135 degrees. You could be talking about 150 degrees. No calculator. You take this, and that's what we were talking about yesterday. The sine of 30 degrees. Which finger is 30 degrees? They're going to have to give you something that this is going to provide you enough information for. We'll get to examples of that, trust me. They're going to have to tell you some piece of information, whether it is what angle has a sine of radical 2/2. 45 degrees. You want radical 2/2, which is in the palm of your hand right there. So radical 2/2. You can say that too. When you fold your finger in, it points to what the denominator should be. So you get that radical 2/2, you're going to get 45 degrees. Tangent of 24 you can't use here. That you're going to have to use your calculator for.